What is the role of astronomy in everyday life, and what was its role for ancient cultures? If you imagine being transplanted to the African savanna 40 or 50,000 years ago, the cradle of humanity, as a hunter-gatherer living by your wits on the savanna, what use would you make of astronomy? Clearly, you would need to hunt game, or the crops, or wild berries that would sustain you. You would need to know how to get back to your encampment by the end of the day so as not to be prey for the wild animals. And you would want to keep track of time so you could plan the seasons and your abodes for the winter and summer, or understand how long a pregnancy cycle would last, or what the cycles of life would mean fitting into the cycles of the sky around you. Ancient people cared about astronomy. It was almost built into their DNA, because they watched and learned from the sky, and it was essential in their everyday lives in ways that it simply isn't anymore. We've immunized ourselves from the night sky because most of us live in cities or suburbs, and most young people have never seen a truly dark sky. But let's for a minute imagine what someone in tune with the sky, living by their wits, and looking at that pristine dark sky unaltered by city lights would have seen thousands of years ago. They would have used the sky to keep time, to track the seasonal cycle. They would have watched the lunar cycle as the most prominent object in the night sky. They would have monitored the phases of the moon, and they would have noticed strange juxtapositions where the moon seemed to go into shadow, or occasionally where the sun was blotted out for a few precious minutes every few years. What would they have made of these phenomena? Remember, to ancient cultures, the sky and astronomy were not just a subject in a textbook. The sky was a map, a calendar, a clock, but it was also a source of myth and legend, a repository of stories you might tell around the campfire, of things you might frighten each other with or inspire each other with. It was a cultural legacy that took a different form for every culture through history. We know that astronomy is built in at the birth of modern humanity. If we look at the oldest human artifacts that we can date, they go back to 30, 40, or 50,000 years ago. There are cave paintings in southern France and southern Spain. There are bones that are carved that date back 50 or 60,000 years ago that were carried around by hunter-gatherers. And in both cases, we see sequence of markings that imply lunar calendars, which is to say 29 or 39 notches in patterns and groups of that number. Of course, these cultures left no written language or written documents. We don't know exactly what they said. But if they'd just been counting kill or prey or objects that they owned, it's unlikely that an astronomically meaningful number would occur and recur so many times, especially in cultures that never communicated with each other all around the world. So we have very strong indirect evidence that the oldest human artifacts that we can find were telling us about the night sky. In particular, they were lunar calendars, and so they were used to mark time. These were the early people calendars that were carried around as they moved on the savanna from different places through the year, hunting their food. We also know that in the days before compasses and GPS, navigation depended critically on the sun and the stars, in particular on the stars at night. In the hot parts of the world, travel during the day was difficult, and so travel would occur at night with a moon to guide you. People had to know their way around by the stars. So those star patterns that are unfamiliar to most city and suburb dwellers in the modern world were etched sharply on the minds of ancient people. This was common everyday knowledge. These patterns could be used to navigate over distances of hundreds or even thousands of miles on land or on water. And we know that this happened tens of thousands of years ago. When we look at the constellation patterns, we think they have no meaning. They don't seem relevant to our modern lives, and in fact the constellations were laid down thousands of years ago. However, to the ancient people, these were mnemonics for how to remember the sky, to help them navigate the complex star patterns. These patterns and silhouettes, of course, are not obvious. Imagination is used to draw the figures of animals and people. And of course, it was natural to attach stories, legends, and myths to these characters. The sky, of course, was a supernatural place, inaccessible to everyday humans, and was given extra power as the creatures or gods that inhabited the sky must have extra powers as well. So let's imagine what would happen if you were a hunter-gatherer thousands of years ago, making careful observations over the course of a year. What would you see? All of these things you could see right now, but of course most people don't have access to a night sky or perhaps the patience to make such observations for a whole year. You would of course notice the patterns of the sky, the rising and setting of the sun, and the fact that its rising and setting position varied throughout the year. You would notice the stars circling at night around a fixed point in the northern hemisphere if you lived in the north, and you would notice that they form concentric circles above this particular point. You would notice through the course of a year a seasonal cycle that was related to the way the sun rose and set, and its rising and setting positions relative to due east and due west. You would of course notice the lunar cycle superimposed on these other cycles, and you would notice how many lunar cycles fit into a seasonal cycle. And finally, without much difficulty, you would notice a small set of interesting objects. They were nicknamed wanderers by the Greeks, planetas, or planets, and these, to the naked eye astronomer, were 5 objects, in addition to the sun and the moon, that move within the fixed pattern of the stars. Because you would also have noticed, over generational timescale, that the constellations never changed, that the stars, while they migrated in circles around a fixed point in the northern sky, they never actually changed their shapes or patterns. All of this you could see in 1 year of observation. And each of these cycles gives us an imprint of time in the modern calendar. The day from the spinning of the Earth, the year from the Earth orbiting the sun, the month from the lunar cycle, and the week, which is a rather indirect reference to the moving objects amongst the fixed pattern of the stars. Here's an archetypal photograph, a time-lapse from old-style photography before digital cameras, of star trails in the southern sky in this case. There's no analogously bright star to Polaris at the center of this picture. If you look at the star trails, you should be able to estimate how long this exposure was as segments of a circle, about 10 hours. There's a nice story that goes with this picture, which was taken by David Malin, probably the world's premier astrophotographer, now retired. He worked out of the Anglo-Australian Observatory, a place where I got some of my thesis data and just visited recently. It took him a while to get this photograph. The Australians are jokesters, and he traveled up to the observatory to take this time-lapse photograph. Of course he wouldn't stay up all night. He would set his camera after dark on a time exposure and then get up before dawn to close the shutter and develop the film. An engineer working at the observatory had a jokey relationship with Malin and decided he would thwart him. The engineer would fly up to the observatory when he knew Malin was there, and figuring out where he'd set up his camera, would go out on the catwalk of the observatory, you can see the dome and the silhouette in the photo, and with backward writing and a flashlight write swear words on his film. So when Malin woke up the next morning, his picture was destroyed. It actually took him months of cat and mouse games going up to the observatory at the last minute trying to fake out the engineer before he got this photo, which has graced the covers of magazines and textbooks. Malin is one of my friends and colleagues, but this beautiful picture of the night sky is something that represents information lost to most modern people, because the average person is simply unaware that the stars do this. Another example of the importance of the sky to ancient astronomers comes from the gorgeous cave paintings at Lascaux and Altamira in southern France and Spain. Unfortunately, these cave paintings are so fragile that most of these caves have now been sealed off and cannot be visited by the public. The damage is too great from moisture. However, the paintings exist online, and you can see the gorgeous animals they drew, that they hunted, but also the pattern of dots, which in the sum of all these paintings show clear signs they were keeping a lunar calendar to mark time in their ancient cultures. If we go around the world looking at how astronomy was used by various different cultures who didn't communicate with each other, we see variations that are quite specific. For example, in equatorial regions where the seasonal cycle is simply not very obvious, there are no 4 seasons as we have in temperate northern climes, time is kept in a different way, in this case by the subtle tilt of the crescent moon at the same part of its phase throughout a season. In Africa, this marks out simple 2 seasons of the rainy season and the dry season. So the sky has been used in customized ways by ancient cultures around the world, according to their local circumstance. Another common feature of ancient cultures is something called a gnomon, which is a Greek word representing stick, and it is, at simplest, a stick which casts a shadow from the sun as the sun rises and sets. And if you trace out the path of that shadow and then trace the envelope of that shadow over a seasonal cycle, you can turn it into a calendar, able to predict the time of year. Perhaps the most iconic structure from prehistory that tells us about astronomy and culture is Stonehenge, from my homeland in the United Kingdom. Stonehenge sits on the Salisbury Plain, on a plateau that's unremarkable, with no towns and forests, nothing nearby. Rises out of the plains these 2 concentric circles of stone pillars, the largest of which weigh 150 tons. Remarkably, the culture that built this imported these stones from as much as 500 miles away. Still, there is speculation as to why and how they brought the stones from so far away, and why they positioned Stonehenge exactly where it was. There was perhaps an astronomical reason. And indeed, some people wonder whether a culture this ancient, Neolithic culture, could drag stones this far with no nearby waterway. But they did, and they built a monumental edifice to culture, astronomy, and their early religions.
5,000 years ago, Stonehenge started life as an earthenworks enclosure, and it wasn't until around 2600 BC that the first stones arrived. These were bluestones dragged all the way from West Wales. The Bluestone Circle was taken down 200 years later in 2400 BC. It was at this point that the greatest building project in ancient Britain got underway. The first of the huge Sarsen stone trilithons were erected. The bluestones were then slotted into the centre of that ring, hinting at their symbolic importance. Then another outer circle of bluestones was added, before the massive circle of Sarsen stone trilithons enclosed the whole thing. This was the heyday of the monument, and it lasted for about 500 years, until around 1900 BC. Over the next 4,000 years, Stonehenge fell into a long, slow decline. Neglect, theft and time producing the iconic structure we're left with today.
In work dating back to the 1950s, archaeoastronomers have investigated the alignments of the stones at Stonehenge and decided that it represents an exquisite calendar, not just a solar calendar, but an eclipse predictor, able to predict patterns in the sky occurring on near-century timescales. This is a monumental piece of work built over 1.5 millennia. Think of how many generations of coherent activity of this early culture were required to create Stonehenge. Stonehenge is not an astronomical observatory. That was anachronistic to think that way. But it does embed a lot of astronomy. Other alignments in Stonehenge give indications that they're tracking Venus, the phases of the moon, and perhaps Mars' position in the sky as well. But the core of Stonehenge is a simple solar calendar where the heel stone, which was lost and then recovered, represents the place where, on the longest day of the year, the sun rises on the horizon. This was a pagan culture indulging in sun worship, so they naturally built their astronomical monument in homage to the part of the sky they worshipped. Stonehenge is large, monumental, but some of these astronomical relics are portable. Something called the Nebra Sky Disk was found in Bavaria a few decades ago. It almost certainly represents the burial artifact from a very high caste chief in Neolithic times, and it's engraved with star patterns and constellations, and it was a ceremonial object, but it also embedded real astronomy. If we go to the other parts of the world, we actually find ancient observatories that almost look like observatories. The Caracol at Chichen Itza has the appearance of an observatory, but that's misleading. There was no telescope here. It was built over a millennium ago by the Mayans. And the Mayans celebrated Venus as the primordial object of their sky, and they actually set their calendar according to serious observations of Venus over the year. And this building was used for sighting Venus. This was very high-status work. The astronomers of the Mayan court were held in high esteem, and the entire culture pivoted around these observations of Venus and this observatory at one of their main ceremonial sites. Nearby, you can see the Great Pyramid of Chichen Itza, and the crowd gathered here in this view of the monument, which weighs about 10,000 tons, are celebrating an extraordinary time which occurs once a year. On the left-hand side, the rising sun over the rainforest in the Yucatan Peninsula casts an undulating shadow up the steps, which rises up the steps as a snake would, and that's indeed the metaphor, and then disappears. This particular shadowing lasts 7 or 8 seconds, and it occurs once a year. One day later, the alignment is no longer perfect and the shadow is not cast. So we have every indication that this 10,000-ton monument, built over a millennium ago, was situated and oriented with the precision of better than half a degree to commemorate the rising sun on the longest day, an exquisite astronomical landmark of an ancient culture. Slightly more controversial work done by archaeoastronomers in Southern and Central America has found pyramid complexes where other astronomical alignments have been seen. In all of this work, it's difficult to be sure of the interpretation because no written language or record of the use or purpose of these monuments is left to us. Closer to where I live, in the desert southwest, there's Chaco Canyon. Here we can look at the Hohokam, a tribe that lived here and eventually disappeared about 1,000 years ago. In a canyon and on a high tor of rock where a natural cave forms, light is admitted through a slit in the rock and casts a dagger-like shadow on the far face. On that far face, that Native American tribe etched a spiral in charcoal, and the dagger on the longest day passes through the center of the spiral. At the equinoxes, spring and fall, the dagger passes tangents through the edges of the spiral. So this is yet another form of a solar calendar, created by Native Americans in the part of the world where I live. The idiosyncrasies and specificities of how these calendars are made are not that important. What's important is that almost every stable culture has chosen not just to commemorate the sun's motion, but codify it with exquisite monumental architecture, often of great precision. Sometimes we simply have no record left to us of how ancient people used astronomy. There's good evidence going back 100 years that native cultures in the Polynesian area were able to travel across the Pacific to Hawaii and even to South America. For a long time, people thought it was impossible that their navigation skills could have led them to dead reckon traveling to an island 1,000 miles away with an accuracy of 10 or 20 miles. But we've since reconstructed the kind of sextants they had and understood that their celestial navigation was quite sufficient for them to do these navigation skills. In fact, from their cultures, these artifacts simply don't survive. When they made their artifacts from wood or paper, we have no record of them. So we're left wondering how they did what they did. But to those cultures, their knowledge of the night sky was exquisite. In fact, the Gilbert Islanders, even to this present day, live in houses which look like inverted longboats, and when the children are growing up, their parents and relatives put colored objects on the ceiling to teach them the patterns of the night sky so that they might learn navigation even before they can walk. Very important records come to us from the long, unbroken cultures of the world. The Chinese astronomical tradition is extremely strong because China had a nearly 2 millennium history of court astronomy, where astronomers made observations, wrote them down, and they were kept by the empire that lasted that length of time. The Chinese astronomical record is an incredible resource that is not fully tapped because there simply aren't enough Chinese or Western scholars to interpret all the information. But what we already know says that it contains a rich trove of data on supernovae, variable stars, eclipses, and transient phenomena of the night sky. And sometimes a discovery from the ancient world simply blows us away. A few decades ago, an artifact was found in the Aegean Sea off the coast of Greece, which puzzled archaeologists. The ship had actually gone down two millennia ago, And the artifact that was found, crusted with mud and rusted and compressed by time, seemed to be a mechanical object. Since its use has been understood in the last decade, it's become known as the Mona Lisa of mechanical objects. It's in fact an analog computer that codifies in an incredible way the observations of the night sky. It's called the Antikythera mechanism. This one object has rewritten the books on the history of engineering. Built this length of time ago from brass and other materials, it includes off-centered gears, and its moving dials on its face codify the positions of the planets, including the outermost planets, including their non-circular motions. Now this is striking and controversial because it was assumed that the eccentric or non-circular motions of planets were not discovered until the time of Kepler. But the Antikythera mechanism uses eccentric gears to show that Mars, Jupiter, and Saturn move at a non-uniform rate in the sky. This is also an eclipse predictor, predicting eclipses over timescales of up to 80 years. It's a showpiece device that was probably being carried across the Aegean in a trading route to trade for other devices or to show how impressive the Greek culture of the time was. Astronomy is the oldest science. If we look at the oldest human artifacts we have access to, we can see that they cared about the night sky and were tracking the motions of the sun, the stars, and the moon, often in a quantifiable way to regulate their lives. For ancient cultures around the world, the sky was a map, a clock, a calendar, and a repository of myth and legend. The richness of the way ancient peoples have understood and worked with the night sky is sobering and a reminder to us that the night sky still exists for us to enjoy.